Hello and welcome to Day 3 Notes. Today we're going to be talking about busting the bee. If you remember back to yesterday's notes, we learned a process of factoring called grouping. That's going to be the method that we're going to continue to use. However, on these problems that we have today, they're trinomials, which means they only have 3 terms. In order to group, we need to have 4. So today we're going to break up the b term. For example, 12x here is the b term, the term in the middle, to 2 terms so that we will then have 4 terms. The first thing that I want to do is identify my a, b, and c term. In this problem, my a term is 1, my b is 12, and my c is 35. With this, I'm going to make a table. On my table on the left side, I'm going to have a times c, and on the right side, I'm going to have my b value. A times c in this case is 35. And my b value is 12. On the left-hand side of my table, under a times c equals 35, I want to find all the factor pairs that multiply to be 35. We can do this by multiplying 1 and 35 together, and also 5 and 7. These are the only 2 factor pairs for 35, so we're done making our list. On the right side of our table, I want to find the sum of each of these factor pairs. So the sum of 1 and 35 is 36, and the sum of 5 and 7 is 12. In order to choose the correct line from the table to be able to bust up our b, the whole entire line has to make the table true. So I need to find something that multiplies to be 35 and adds to be 12. You can see that 1 and 35 multiply to be 35, but they add to be 36. So this cannot be what we use. But 5 and 7 multiply to be 35 and add to be 12. This is exactly what we need. So now I'm going to take my problem and rewrite it. So I have x squared plus 12x plus 35, which we're now changing to x squared plus 5x plus 7x plus 35. I have not changed the integrity of this problem at all. If you simplify the second line of this problem, you will notice that it goes right back to our original problem. The only thing that I did was split up the 12 term to make 2 terms. Okay? Now we're going to use the grouping method to factor the problem. So I'll group my first 2 terms and my last 2 terms together. I'll find the GCF of my first group. The GCF here is x, and I'm left with x plus 5. I'll find the GCF of my second group now, which is 7. And what is left over is x plus 5. Now, this is the part that will get you confused a little bit. We have to remember that we have to take the GCF one more time. We want to take the GCF from this entire highlighted expression. So the GCF is something, the greatest common factor, the thing that shows up in both terms, the highest factor that shows up in both terms. The only thing that shows up in both terms in this case is x plus 5. When we factor out that x plus 5, we're left with x plus 7. Now we're going to continue with number 2. So the first thing that we want to do, just like the previous problem, is identify our a value, which is 1, our b value, which is negative 10, and our c value, which is 25. And we're going to make that same table that we just created for number 1. On the left side of our table, we're going to have A times C. And on the right side of our table, we're going to have our B. In this case, A times C for problem number 2 is going to be 25. And our B value is going to be negative 10. Now I need to list all the factor pairs of 25. Our first factor pair is 1 and 25. And then I have 5 and 5. The goal of this problem in this table was to find a factor pair that adds to B negative 10 so that we can bust the B. Right now, if I add 1 and 25, I get 26. And if I add 5 and 5, I get 10. Positive 10, not negative 10. So we need to discuss a little something different. When I make factor pairs, I usually come up with a list of positive numbers. But there's actually 2 ways to get a positive number through multiplying. We can always multiply a positive times a positive to get a positive. We can also multiply a negative times a negative to get a positive. And the third case, which doesn't apply in this situation, but we'll go ahead and talk about it, is a positive times a negative is a negative number. Since I have a positive 25 for A times C and a negative B, and I figured out that my 2 positive factor pairs don't work, I'm going to take my factor pairs and I'm going to make them all negative numbers. Now it's going to give me negative 1 plus negative 25, which is negative 26. Then negative 5 plus negative 5, which is negative 10. This now gives us the correct numbers that we needed to make our statement true. Our A times C is true and our B value is true. So now I'm going to rewrite my problem. Instead of having V squared minus 10V plus 25, we're breaking up that B value, or the negative 10, to negative 5V and negative 5V. Because when those are combined, again, it goes back to equal negative 10. I've not changed the integrity of the problem. I've just made it to where we can work with it better. Now we need to group. So I'll have V squared minus 5V in my first group. I always put a plus sign between my 2 groups just so nothing has to be changed. I don't have to change any signs after it, and it just stays the same. Plus negative 5V plus 25 for my second group. I'll take the GCF of my first group, which is V. I'm left with V minus 5. And the GCF of my second group, which is negative 5. And I'm left with V minus 5. Remember, like the last problem, when we get to this step, we have to take the GCF one more time. The GCF in this case is going to be the group, or the greatest common factor that shows up twice. In this expression, the greatest common factor that shows up twice is V minus 5. Right here and right here. And I'm left, after I factor out V minus 5, with V minus 5 again. Now we're going to move on to number 3. One thing that we need to discuss when we're talking about busting the B and grouping and just factoring in general is that we always need to verify that there's not a greatest common factor. In the previous 2 problems, there was not a greatest common factor. However, in this one, there is a factor that we can pull out from all of the problems. My GCF here is negative 5. When I pull out that negative 5, I'm left with k squared plus 16k plus 63. And now I can go ahead and identify my A, B, and C value from my factored equation. So my A value here is 1, B is 16, and C is 63. We can go ahead and make the table. On the left, we're going to have A times C, which is 1 times 63, or 63. And my B value is 16. Now I'm going to find all the factor pairs for 63. I have 1 and 63, 3 and 21, and 7 and 9. I need to find the factor pair that when it's added together, it comes out to be our B value of 16. So for our first factor pair, 1 plus 63 gives me 64. 3 plus 21 gives me 24. And then 7 and 9 gives me 16. So the only factor pair that multiplies to be 63 and adds to be 16 is our third factor pair. When I rewrite my problem, notice that I'm going to rewrite it with the GCF out front. So negative 5's out front. I have k squared plus 7k plus 9k plus 63. And I can go ahead and group my terms. I keep the GCF out front, that'll never change. And now I want to take the GCF of my first group. The GCF here is k, and I'm left with k plus 7. My GCF of my second group is going to be 9, and I'm left with k plus 7. Now I want to take the GCF here. So I keep my original GCF of 5, and my GCF of this section is going to be k plus 7, and what's left over is k plus 9. And that is the factored form for number 3. Alright, we're going to skip down to number 6 really quick. And I want to go ahead and identify my A value, my B value, and my C value. In this case, A is 1, my B is 0, and my C is negative 81. This might seem a little tricky at first, however, you'll see the pattern in just a second. I'm going to set up my table as normal, A and C, A times C on the left, B on the right. A times C is going to be negative 81, and B is 0. So earlier when we were talking about factor pairs and multiplying them, we said that a positive times a positive is a positive, a negative times a negative is a positive, and a negative times a positive is a negative. We see that 81 is negative, and the only way that we could get there is to have a negative times a positive. So let's list out our factor pairs. So I have 1 and 81, 3, 27, 9, and 9. The only way that we can combine one term with another by addition to make it equal 0 is for one term to be the exact opposite of each other. So either way we changed it, negative 9 and 9 would add to be 0. And that would give us our two factors that we need for this problem. I've gone ahead and worked out this problem on the right-hand side. I split up my middle term, which was 0, to positive 9b and negative 9b. Because when you combine those together, it adds to be 0. I took the GCF of both of my groups, simplified, took the GCF again, and I got b plus 9 and b minus